This conference will now be recorded.
I just
All right,
gave
Kev,
you, Gary.
what is yours?
Presenter.
Okay, give me just 1 minute because it needs one more password, one more thing to permission-wise. Wow. Okay.
You may have to go out again.
Okay.
Yeah, the great balance of security versus usability, right?
You know, It's- just want to share my screen, please.
Okay.
One second. You came in, you left and came in. We had
Now
to
you
give
got
you
the
on
presenter.
the other one. 1 second.
No worries.
There you go. You should see the screen button next to the camera on the bottom.
Okay. Oh, later. Let me see. Will it let me? There we go. There we go. Now we got it, right? Sweet.
There we go. Now we see it. All right. Perfect.
Woohoo! So we're gonna do this. I'm not gonna get so heavy into the blockchain. Some of it is gonna be just me going like, very much like I want to do this like a question and answer kind of thing. But I also want to make it interactive with everybody. But anyway, I want to introduce myself, Kevin Tucker here. I've been part of various cybersecurity organizations, nonprofits. Rod knows, we go back quite a bit now. This is a couple of years I've been knowing him and Marco. But PHAC is an organization, and I know HackMiami is we're all connected, right? We're all trying to help everybody kind of understand cybersecurity is everybody's responsibility. And I kind of look at it like this too. Since we're all working from home and we all have our own networks, we're all kind of our own CISOs. So I have this, new kind of mindset where I tell everybody, we are all CISOs at the end of the day, right? We're the gatekeepers in our own domain, trying to keep our network safe and our friends and family safe. So with that being said, yeah, I'm going to talk today about cryptography, not so deep, but blockchain, and kind of get into the underlying technology. Because I think, being that I've been in IT most of my career, cryptography is fascinating, but discrete mathematics and you get into some of the science, and that's when you start to open up the understanding of why blockchain is very important, and mass adoption in various ways has been, we've seen an uptick in it, and now everybody's talking about, kind of how blockchain is changing, the landscape and the web, and the way we see it. But just kind of starting out, I want to talk about the blockchain in general and kind of getting into the deeper aspects of it. I know there's a lot of different protocols, but I'm just going to stay kind of neutral, agnostic, but I'm going to try to touch on kind of the bottom line. Where I want to really take this conversation to is just to kind of just touch on the kind of the basics. So don't expect a high level overview of discrete mathematics kind of talk. It's just going to be some simple kind of going through everything. So without a doubt, first of all, this is just what you need to know about it. Let me see if I can get my first slide. So blockchain technology, what is it? It's a protocol, right? Just like everything on the internet. And with that being said, I'm going to try to move this here. So hopefully I can minimize it and bring it back up. It's a software, but it's a protocol for a secure transfer of unique instances of value. So we're talking about digital assets, money, property, contracts, identity credentials, and the internet, is the key here. Without requiring a third party, intermediary such as a bank or government. So that's the thing that people are fascinated by, right? We see some examples here, right? With email, phone calls, this is the voice over IP. We look at even with Bitcoin, all these things are basically riding on top of what? The internet. But with these protocols, secure transfer of unique instances of value, that's where it becomes very unique, in the sense of understanding money and property, right? Because that's kind of where our societies exist on. And you look at these contracts and identity credentials, this starts to open up a lot of doors with security. But then you start getting into some of the other things, the use cases. Just for instance, you scan a recipient's address and submit transaction, and then it appears in the recipient's e-wallet. So we're talking about ways to transfer money now, digital assets. People kind of understand that, but the wallet, has keys, not money. So that's another thing, in terms of security. So it creates a PKI signature address and then a new PKI hash signature for each transaction. So that's the whole thing about the public and private keys that is so important. Obviously, we know we never want to give someone our private key, and public key is available to anybody on the blockchain. But your private key, you should never ever have that be something that, and you see this a lot with people. They'll get solicited on Discord. I've seen that not a lot now lately with the bots. They'll say, hey, there's this new crypto. We want to give you an airdrop or something. So you have to be mindful of that. But this is kind of how I'm jumping a little bit ahead, but I want to show you how kind of Bitcoin works in the wallet app. But then you start getting into this, like the pay to play network, and it confirms the records and the transaction. And this is kind of going through how the transaction is submitted, and then the miners assemble, and then the whole transaction, how long it takes. This is the thing that you got to really be mindful of. And then you get into this thing where you have the ledger, and then the transaction computationally is confirmed, and then the ledger action balances is updated. So it's like when you go to a bank and you go and you say, hey, I want to deposit $25. They have an internal ledger, and that ledger is shared between all the banks. The difference is, we go back to where I was before. When you have a transaction that goes between recipients, it appears in the recipient's wallets. Well, this is the underlying technology that we're talking about. What's going on here between Bob and how this transaction is encrypted, and then the signature, this is the PKI hash, and then it goes through the decryption test. So this whole thing that I'm going to touch on is going to specifically talk about the hashes and how we get into discussing about really what's underlying this cryptography, the whole mathematics, discrete mathematics, in the sense of the miners, they get a reward for the transaction, and then it appears in the recipient's e-wallet. So this is the kind of the future. This is why I want to talk about the blockchain technology and the use cases. But we got to remember, this is all part of the new, what they call the Web 3.0, and it's the new kind of like the version we were witnessing is the version 1.0, and then now the Web 2.0. And then you get into this whole thing about understanding requiring a third party, it's on the internet without requiring a third party intermediary, such as a bank or government. That's the most important part. So I'm going to jump into a little bit here. Let me get a little bit ahead. Give me just a second. I want to make sure I get to the right part where I want to explain a little bit more about the protocols, because I've got some things I want to touch on before we get into this. So because so here's the key concepts of the blockchain, and this is where we get into understanding how the blockchain, when we got trustless versus trusted distributed networks, consensus algorithms, and immutability. I'm not going to jump deep into these, but the blockchain has these various concepts that we can distribute it peer-to-peer based. So you have to think of it like when we were in the days of torrenting and BitTorrent. It's the same kind of concept, right? Is it just you had on your computer, you had some of a like a basic understanding of all the computer power together. We share some of the same content, right? So each person is basically part of this distributed network. Well, within it, you can start breaking it down to immutability, right? That person that has some of that content basically is immutable on the blockchain side. So that's why I want to touch on some of that stuff, but I don't want to get too deep into it. But another thing is a ledger is like a database, and like a spreadsheet, and you can add new records by appending rows and that kind of thing. And each row has information, account balance, who owns. So this is technically kind of like what a ledger would look like. So there's Alice's $500, Bob has 10, Charlie has 1,000, right? The account balance and balances and who owns, certain assets is basically described here. So when you go to the bank and you say, hey, I want to deposit money, remember I talked about the ledger that's shared, it's shared amongst all the banks, right? So the banking system has that ledger, and that ledger is basically what they use as a way to say, hey, on the day that you came in, you deposited this amount of money, and this is what we'll basically say is going to be subtracted or added to your account. But this is the difference, right? With the blockchain, you have the memory and execution state of a computer program, which we talked about. Why is it distributed? The distributed network, many nodes or peers that are connected in a network, and there is no single point of failure or centralized control. Security and resilience design the network so that if someone or some peers crash or attack the network maliciously, the network can still operate. And this is what we talk about, the Byzantine fault tolerance. So the main thing is understanding distributed network. That's just one protocol, and that many nodes or peers that are connected in a network with no single point of failure or centralized control. That's the distributed version. And it's immutable because you cannot change the data once it's committed to the ledger. Data is auditable. It's not able to be audited. Very much like you can't go in, and what I mean by that, you can't go in and manipulate it. Once someone it commits to the blockchain, you can follow that, and that's what makes it very easy for someone to see the transaction. Also, you change by issuing offset transactions, and then there's a smart contract code. This is the big one that I know a lot of people are starting to realize too. The smart contract, you have to have that smart contract. Without that, it won't proceed. And the other thing that's interesting about the smart contracts, if you notice with all the lately in the news with all the hacks, it's always got something to do with the smart contracts. And there's different ways in which you can manipulate that, but I won't jump into that as deep. But the point is, what I'm saying is the smart contracts are kind of the core of the situation. So this is where I wanted to talk about the cryptographic identity. To use a network, it needs a cryptographic identity, sort of like an email address. If you want to access your email, you need the password and the function similar to a private key or a public key is like your address, but it's more complicated. You've probably seen those hashes, and you've seen exactly what it sort of looks like. Everybody kind of here should be knowledgeable about looking at a address on the blockchain, but it's just a series of numbers and letters and things like that. Authentication peers sign transactions with their cryptographic identity and enables account ownership, and they can attribute blame. Basically, that's when you can see the transaction, you can see who's basically behind it and what's going on. Then this is the consensus in the distributed network. This is where you have, in order to update the ledger, the network needs to come to a consensus with an algorithm. What does it mean to come to a consensus on the distributed network? It means that everyone agrees on the current state of how much money does each account have, and making sure that no one is double spending money. Easy in Bitcoin, more complex in Ethereum, and it's true because you have to look at the various protocols and the underlying how they're basically computations are being executed. And how do we come to consensus on a distributed manner? This is another one that I'm starting to notice where they're talking about a DAO now, which is distributed autonomous organizations now. So there's like basically a governing body, and they all vote, and it's kind of like, ways in which they can kind of maintain a sense of, a way that they can each look at it from a security standpoint and say, hey, is this really, do we have a consensus on this? And, it's getting more and more complex. And as we talk about this stuff in real time, there's a lot of decisions being made about how these DAOs are going to govern each of these different various protocols, that are based on the blockchain. But it is true. How do we come to a consensus in a distributed manner? Is it going to be equal? Does everybody have equal say? but it means that everyone agrees on the current state, and this is the big one. You know, how much money does each account have? And this is again going back to some of the ways in which, you know, no one is double spending money, and it's easy in Bitcoin because you can double spend, and that's a whole different talk. But basically, that kind of, you know, is one of the bigger problems with the fact of, you know, the different ways in which you can look at, you know, protecting yourself. But there's three primary consensus algorithms. There's proof of work, expensive but not ecological wasteful computations. There's proof of stake, Ethereum, Bitcoin is proof of work. Also, you get this thing about, you know, the Byzantine fault tolerance. And then, you know, you have large numbers of diversity of participants, you know, and then for each block of transactions, randomly select a small one-time group of users in a safe and fair way to protect from attackers. The identities of each user is hidden until the block is confirmed, and then the size of the group remains constant as the network grows. So that's a consensus. That's the three primary. So it's proof. You always hear about the proof of work, the proof of stake, and then, you know, the basic understanding of the Byzantine fault tolerance. Also, you know, public-private networks, trustless versus trustless, distributed networks, consensus algorithms, and immutability are some of the things that, you know, I won't jump into each of these so much, but I will talk about the trustless, distributed, peer-based, consensus-driven, immutable. That's kind of what sums up where each of these share the commonality: trustless, distributed, peer, consensus-driven, and immutability, which means, you know, that the bigger part is, this is where, you know, a lot of people understand from a security standpoint, and from, you know, when you look at real estate or some of the other use cases, if you look at how this is being able, like a database, right? You have a database and you want to make it immutable so that, you know, hey, this is the person that who's identified based on, you know, their own, like say your social security number, or, you know, something that identifies you. You basically can have that available and it's immutable, right? So you know that no one can say, hey, that's not you. And in the bigger picture, a lot of companies have started to adopt that to make sure that you are the person you say you are. And this is sort of like your real estate. If you look at the real estate market, they're picking up on a lot of this because they know that, hey, you know, if you say you bought this land, then we know it's basically yours, and this is when it was committed to the blockchain, and so it's immutable. You don't have to go into a courthouse or someplace like a title company and ask them, hey, who owns that land? You can just look it up, and it's public record. So I hope that makes sense. This is a kind of a what does the blockchain solve? This is kind of the thing about going to the, you know, a bar, and then, you know, kind of the scenario, who wants to tip. Basically everybody can chip in, and, you know, with that being said, you know, you don't have to think about, oh, well, you know, if everybody chips in, we all have an equal part in that, and it's not centralized and everybody has, you know, benefited from it, but we can all, you know, share that commonality. Plus, you know, it's not distributed through you know, the fact that we talked about distributed networks. You know, it's basically driven by the fact that it's immutable and it's trustless. So that's the biggest part of that. I did want to say that anybody have any questions real quick, because I can pause for a second. I know I threw a lot of you know, this topic is kind of can go all over the place, but did anybody have any questions real quick? Okay, well, I'll continue. Basically, you know, now I'm going to get into a little bit of the different concepts. Give me just a second. How much more time do I got, guys? Let's see here. It's 1:30. I will continue. Give me just a second. I want to jump into my other. Give me just a second.
You have plenty of time. Still 35 more minutes. So.
Okay. Give me just a second. I need to do something. Am I still sharing my screen, or do you guys see it?
No, just you.
Okay. Just trying to change to my other slides. Okay. Give me just a second. I'm almost. Okay. All right. Just a second. I'm gonna get back here. All right. So now I kind of want to slow down and just go back to what we were talking about earlier, which was basically getting back to a blockchain is a sequence of hash chain records. You know, once you've seen the record in, you can not change anything in the past. Some procedures for adding blocks to blockchain. Who gets to add the blocks? How is it done? Validity conditions for new blocks. Are transactions valid? Are digital signatures correct? And it's enforced by consensus. That's what we talked about earlier. And then chains with invalid blocks won't be accepted. Some procedures for deciding between alternative candidate blocks, blockchains. This is what we were talking about the Alice and Bob scenario. But basically, how does it work, right? Building blocks, cryptographic hash functions. A cryptographic hash function takes a tiny bit string as an input. It's like a 10 megabyte file. It produces a fixed length output. And then basically, you know, nobody can find collisions. This is another part of them. Then we talk about the SHA-256 and different, you know, algorithms. Sometimes they're really huge. And this is when we get into the different ones like Bitcoin and why the energy consumption is so heavy, because it takes a lot of power, the computing power to deal with, you know, the aspect of handling all that, you know, transaction rate. And then I've noticed too, it depends on which you know, blockchain protocol you're on. Again, we're going back to like Ethereum, or is it, you know, Bitcoin, or, you know, various ones that are, you know, out there. You can experiment on your own, but that's when we got into the discussion about how fast, you know, the transaction rate and how easy it is to the computational reward that the miners get. So what is a collision? Suppose I find two different inputs, and then, you know, that's a collision, hash and hash. And then for a cryptographic hash function to be any good, it needs to be collision resistant. That means it's possible in practice to find collision inputs. I'm not going to get too deep into the math, the discrete mathematics stuff, but you know, it talks basically. I want to, you know, keep the talk very light, but if anybody gets basically the same hash, then that's when it's a collision, and it won't commit. You know, the hash chains, it goes through a sequence of records linked together. Each record contains the hash from the previous record. You can kind of see here from the previous record. So this is the part that's immutable, right? So you can follow the path. So a lot of the thing with Bitcoin is it's so many different things that have to happen by the time it, you know, the transaction rate. It's just a lot of computational power and energy. So people are looking for alternative means in which to, you know, execute these rewards to the miners, and obviously for the transaction to succeed. You know, what's a hash chain? A hash chain is a sequence of records in which each record contains the hash from the previous record in a chain and a hash of all the current record contents. So this is where we were talking, I was mentioning about the real estate, or you talk about the records, they're immutable. So this is the thing. If anything is changed, it won't proceed. And it will show that something was basically changed before. So therefore, you know, someone can go back and look in time and say, hey, you know what? This was supposed to be, you know, let's just say 25, and then it got changed to 26 here, but then it goes and it will fail. So that's basically what's a hash chain. It's immutable. Was that by basically this is if you're using a cryptographic hash function like SHA-256, that means nobody can find two inputs of the same hash value. And then you can get into some of the math stuff, but basically these are the things that are underlying the blockchain. You know, the attackers can change the payload here, right? And they change one record in the hash, it propagates forward and changes the hash. This is what I was talking about before, how you can manipulate it, but it will be, the attacker can change the payload, but you will start to notice, oh, look, and it'll change the outcome, right? And then you can trace back and see where the attacker has basically manipulated it, and that can be, you know, obviously, you know, identified, because then you can see that that was manipulated, and it's not the same you know, as it previously was. And so that's the good thing about the blockchain from a security standpoint. And it's a lot deeper than what I'm touching bases on, but I don't want you to you know, there's a little bit of research. I'd say each person here at this today's presentation, you should look at it for yourself and see exactly what's going on if you want to really get granular and deeper with the mathematical side of it. But basically, once this is done, it changes this, and then you can see, and then, you know, you can identify, hey, that's obviously, you know, been changed and manipulated. So hash chains and blockchains have the property that every record contains the commitment of all the previous records. That's kind of the gist of what I was saying basically here. And when you get to this point, you know, that's where it's immutable. And then you have, you know, a system with a trusted arbiter who can use the hash chain to limit the arbiter's power. Even the arbiter can't change the history. This is a big one, because with the hash chains, you get into this whole thing of understanding, if you change the end record, this changes the final hash of n plus 1, n plus 2. And once we have the accepted record n, we have locked the contents of the record 1, 2, 3, n minus 1 as well. So blockchains use hash chains as a component, but it's also where you can find the fact that, you know, this is the immutable record, and every record contains a commitment of all the previous records. This is going into the hashes and the nonce and some of the other things. A blockchain containing 3 blocks contains the hash from the previous block. This is, again, getting a lot deeper into it. But, you know, I just wanted to touch on some of the other aspects of it. The building blocks, validity conditions, there's other things too. Signatures needed to be moving forward from the block, from the Bitcoin from an account, not allowed to leave the negative balance in the account. Blocks must contain correct proof of work, which is basically going back to where we were here, which is talking about the consensus, you know, aspect of it, knowing that the previous record contains the knowledge that this was not manipulated in any capacity. So with that being said, I'm going to jump into a little bit about, I don't want to get into too deep here, but the proof of work, you know, I want you to do a big computation. I want you to prove you did it, and I do not want to do too much work checking the proof. So you'll hear that proof of work a lot. Why it's useful: it limits the rate of new blocks, and you know, provides a clear way to decide between competing chains when there's a disagreement. Not all blockchains use proof of work. This is what we were talking about: proof of stake, proof of work. It basically provides a clear way to decide between competing chains. Like I said, if there's a disagreement, which goes back to the point what I was saying, if the previous record is changed and manipulated, then you know for sure, you know, something is been manipulated, and it won't continue to you know, proceed. But basically, proof of work in every block, there it is. You know, did you do the work? There's the hashes. There's 3 blocks in the chain. Then you get into this whole thing, and the first block is you know, it's kind of the one that's like the Genesis block, and then, you know, it appears to be the second block, you know, but, you know, proof of work solves some problems, but not everything. We can resolve disagreements when chains fork, take forks with most work. Basically, when there's a tie, keeps working until the chain has the most work. Discourage people from trying to add invalid blocks to the chain. You spend money by adding a block to the chain, but if it's not valid, no one accepts it. This is a big one. No one accepts it. If that's where we go back to the immutable part. Part of how Bitcoin's very clever design and incentives work, which is the thing about getting the reward at the end of this computational, the whole computational reward system, which is why the thing with when you can resolve the disagreement, you know, hey, did this really added by this person? Was it really the actual, you know, is it valid, or does nobody accept it? Which, you know, you get into these things, you know, that are pretty interesting situations legally, and you start to explore how, what will this look like in the future is what I'm thinking, like 5-10 years from now, and how will we resolve it, right? Will this be something that is easy to find, or will it be more complicated, especially when we get into, you know, quantum computing and some of these other things. Basically, you know, it's, you know, some of the negatives are it's expensive, lots of energy used to do to generate proofs done by the miners in Bitcoin, use special purpose mining rigs, optimized. And some of the negative environmental impact is a lot of people are talking about. And it's slow. Proof of work seems to put a limit on transaction speed, even more when you consider the need to resolve potential disagreements. Bitcoin's rule of thumb is wait 6 blocks for an hour to be sure of the transaction. And this whole thing, I'm going to surmise, but basically it takes a lot of work and it's expensive, and the environmental impact is it worth. So mass adoption to have something like this is not realistic, right? But the blockchain technology is there. So there's a lot of various protocols that are set up to eliminate and reduce the amount of environmental impact, to make it easier, for these blockchain protocols to exist in our infrastructure, and also the environmental impact that uses a lot of power. So accomplishing no useful goal except for keeping the blockchain working, which is why you have these other protocols. Some of them resolve some of these problems, and I don't know, what the future is looking like, but there's a lot of talk about, various protocols that are way less transaction speed. They're just not, as popular as Bitcoin, obviously, for the reason that people want to, utilize it still. But that's mainly, the reason that I talk about the blockchain being more important, because if you don't understand what's happening on the, the level of the underlying technology, then you just jump into the cryptography part, and listen to people tell you about cryptocurrency and not understand kind of the history behind why the certain coins, if it's Bitcoin or if it's Ethereum or whatever whatever protocol, you kind of have to understand what's happening under the hood, what's happening, and why it's happening in the way it is, and why is it slow, right? Because it's the proof of work concept. So then we got permission blockchains, an alternative to proof of work. We have set of somewhat trusted entities who can work together to add records to the blockchain. And then this gets into, some of the stuff about having 5 trustees and you have 3/5 vote and accepting a block to the chain, and then the block is added validity conditions for each block. You got to have, a certain number of consensus, and then, resolution for conflict chains, look for the longest chain. That's another factor. Someone would have to vote for 2 competing blocks, which is getting into some of the more complicated. Like I said, again, a lot of this stuff is on a level of like discrete mathematics. So, and then it starts to look very much like you look for all these various conditions, and that's another thing about the proof of work concept. That I think is kind of cumbersome, but over time I think we'll eliminate some of that. Incentive design, then this is kind of the other blockchains, or especially permission ones, have to find alternatives to incentives, because with Bitcoin's design, the incentives are basically this untrusted self-interest, and the miners keep the system working. They have a big incentive to follow the protocol, and they have substantial capital invested in Bitcoin. So they have a lot of, but now that's starting to shift, right? This all works because Bitcoin is all about moving money around. So yeah, the payoff into the protocol is easier. But now you have a lot of other coins that are, like the underlying technology is better, and you have a lot of more, ways that you can find alternatives to incentives. And then why do we have these trustees, existing business or legal arrangements? These are some good legal questions and some ethical questions, reputation. And then, we have a problem, then you got to, and then you go to jail problem, which is some of the things that we're seeing with the fraud, right? Some of these underlying things are questions that we have to think about from a societal standpoint. Does anybody have any questions? Anything they want to bring up? I know, how much more time do we have? I just want to be mindful. I can keep talking, but I want to make sure.
You have all the time you want.
Okay, give me a second. All right, I want to fast forward. Into some of the stuff that I want to jump into. All right, this is the last one. All right, so I'm wrapping it up a little bit, but blockchains, one thing is they have different use cases, but why don't we don't have to trust each other, and we don't have to have a trusted third party. The system is distributed, agree on history, agreeing on the state of the system, which is kind of the immutable part, right? But the other underlying factor is the end record and the hash chain commits to all the previous records. You can't change any previous record without making hash chains invalid. The blockchain is a hash chain with some other stuff added, validity conditions and ways to resolve disagreements. Also, permission versus proof of work. Most blockchains and now use proof of work, and many new proposals use permission blockchains and some setup of somewhat trusted entities. There's so many different protocols. I don't want to get too deep into all of them. Proof of work, proof of stake, proof of storage. I know there's so many different ones coming out every day. And like, again, it says probably more I don't know about. Some that I can think of and some that I can't. But just because there's so many new ones coming out every day, especially now that we're getting into a lot of legal issues where people are starting to explore the NFT world and all this other stuff. But I just wanted to, that's kind of the gamut of my talk, and we can get into some questions, and then, but I'm just gonna, be mindful of the time and let people know, I hope you learned something. And I know I went kind of fast and high level, but I just kind of wanted to touch on some of these things.
Thank you, Kevin, for the presentation. I have a question for you. What's your opinion of the proof of work, proof of stake? Do you think that this would help cryptocurrency become sustainable from the environment part? Because I guess that's a big worry right now.
Yeah, I mean, I think what we have is where, from an environmental standpoint, I believe so. That's why I didn't want to get into the cryptocurrencies and talking about like Ethereum and, you got XRP and some of these other ones that are, very much more. I think, XRP is probably, from a environmental standpoint, we know that the transactions are much faster. It's less energy. And but I think that one definitely is ideal in terms of how it can benefit in a bigger picture. And I know everyone has their differences and opinions on it, but I think it's gonna come down to what's the payoff, right? And how can we as a society because I know proof of stake, it uses random selected miners to validate the transactions, and then proof of work uses a competitive validation method or something to confirm the transactions and add new blocks. But I know there's different like Ethereum. I think it will replace it in my opinion. But I think because of Bitcoin's popularity, everybody is excited about it. So it's kind of like right now we're in the experimental stages of figuring out which one is going to be more for mass adoption. Was there some? Let's see. I see. What's your definition? I see some. Did that answer your question, Rod?
Yeah, that's fine. Thank you.
Okay, and then I saw one. It was, what's your definition of Web3? Good question. Definition of Web3 is, from what I understand, it's pretty much a decentralized internet built on the blockchain. But it is kind of the new thought of how we will look at it. The existence of how these things that are kind of now we're starting to see more or less, with the maturity of the internet. We're seeing things like, they're talking about the metaverse and all these various, things where we can explore, like, virtual reality. Because, being that the internet came from like the Yahoo days of, where everything was 1.0 and 2.0, was really flat, right? We had hyperlinks embedded, but now you got the 3.0s, like you got streaming video. You have the ability to have, if you think about it, the metaverse is really, when you look at video conferencing, which has been happening for such a long time, but it's kind of like, you get a chance to, get a view of someone else's world without having to be in the same room, right? So that's kind of a preemptive, to me. It's kind of like the new thought on it. And then you have all these VR and AR, like the various, blockchain entities now that are starting to talk about, the way in which we'll explore that stuff. Like the Web3 internet, it's going to be permissionless, and it's going to be, meaning anyone can use it and without having to generate access credentials or get permissions from a provider. That's the thing, right? So when you have all these questions about, how the internet is governed, it's like the DAO. That's why I think the DAO is, decentralized autonomous organizations. We're going to have something like a Web3 kind of, that kind of a thought process where we're going to have to look at governing who's going to be in control of all the not so good things about the internet, right? Because if it's permissionless and anyone can use it without having to generate access credentials, that's just going to open up the floodgates to a lot of these things that we haven't even, begin to explore. So, that's why it's very important to understand, why, companies like, if you look at the big players, all these companies, they have all these, services that they offer, but they also harvest the data that we have, right? So what's happening to all our data and how they're using the data, and then it's basically, how is that data going to be, how is your data being stored, and what capacity? Think about it from a decentralized aspect. That means you can't hold anybody accountable. It's pretty much, it's a free for all. So all that information is published on the public ledger of the blockchain too, which is kind of going to be kind of a very, I think in the long run, if someone says, hey, I want to put something negative about you on the blockchain, what are you going to do to protect yourself? And I think with Web3, there are benefits. There's a lot of good things, but there's also things that we have to be careful of. But the Web3 application side is like the peer-to-peer payment system, and it works on a blockchain. Instead of using a bank, people could pay for goods and services and using different, what they call decentralized apps. That part is fascinating. And then, before the transaction is finalized, it'd have to be verified on the network and then coded into the digital ledger of the blockchain. That part is going to be, a very interesting, part that I think the digital revolution is going to go, into a new realm of possibilities. So, because we know the payment system. If you have to go to open a bank account, some people don't have the means to open a bank account. So that's how it could benefit you. And obviously, if you are, say, you have issues with credit or something like that, you'll be barred from that, but without a doubt, that kind of opens up the door. You could, have a lot of these people who may be, kept out, so to speak, right? Barred from the, as with the credit system and the banking system, if you don't have these things that, they deem, qualify you. It's just like getting a house loan. It's the same concept. So I think with the Web3, I think the Web3 applications that you can build, especially, now you have all these various blockchains, and it's just fascinating. It's very much, I think, the next level. You'll see a lot of mass adoption for some of these things that are gonna, kind of companies that are gonna be spawned from that. I hope that answered the question. Am I using any Web3 apps at the moment? I do not use any myself, but I think I'm fascinated by it. I'm still discovering a lot of these, but I do explore a lot of this stuff, doing my own research. I think, there's so much happening with the Web3, but it's basically like, you have to look at Ethereum and some of these other places that I've seen. I've seen some really cool stuff, being built, and I know there's, all these, the metaverse is a huge thing. We need to kind of think about it, the metaverse has kind of been around for a while when you think about it from Second Life and some of these other video games. So it's kind of now become more popular because now with the dApps and things like that, you can build your own pay-to-play systems and things like that. So I think it's very fascinating, but you know, it's still in something that I'm still exploring myself. I don't personally, I'm not that you know, I love gaming, but I think the next level of gaming from my perspective, like with the Oculus and things like that, it's going to go into a newer kind of a realm of the full immersive experience, which will be some of that. So, and it ties back into the, again, like I said, so that's what the importance to me of the blockchain, because if you look at NFTs and all that stuff, you can have full, you know, full ownership of your you know, of your asset, your game. You know, if you sell the tokens or if you decide to go in the realm of looking at it from a, you know, from an artistry, you can control a lot of that stuff without having to go through a third party, right? And then you can manufacture what you want based on how you want to, you know, distribute it and to who. And it's no middle person, right? It goes straight to you, the reward. So you can scale the game, or you can control how you want the licensing. And so some of that stuff is very fascinating, especially, you know, now that you have so many different protocols and various means in which you can, you know, create the game based on those dApps. Is there any more questions, anybody? Nice. Well, I appreciate everybody's time. I know I jumped a lot around, you know, and to be honest, this is a deep topic, and you know, it's something that you can get into some of these, you know, various blockchain, you know, protocols, and there's so many, you know, ones that are popular. That's why I try to stay agnostic, but also, you know, I feel like you know, look at the one that means the most to you and kind of explore that. And I think beyond that is like for the blockchain, a lot of people jump into kind of cryptocurrency without understanding the blockchain, how it's all connected. And, you know, I think that's the more fascinating part of it, the cryptographic hashes and some of the discrete mathematics and some of the stuff associated with crypto, but it's more of the blockchain and why certain blockchains are, you know, more or less, you know, being promoted. You know, like I said, with XRP and some of these other ones, you know, you start to look into that and you start to find out, well, why aren't we all using that? If it's, you know, less transaction speed and it's better for the environment, but there's different ones that are for different use cases. So I think it just depends on your use case.
I have other questions, and hopefully you can tell me. Do you think you can come back and probably in the next half and give us an NFT presentation?
Yeah, that would be awesome. And you know, I probably with that one, I would love to bring in like a guest or something that really we can get a little bit more deeper with some of that stuff, because I think it would be fun to have like more of a, like some people use NFTs for different ways, and I think it would be good. But yeah, I can do that.
That's great. Well, thank you very much for this awesome presentation, and for all of you for attending. Somebody has a question?
Yeah, KT, is your handle KT in our Discord?
Nah, I'll send it to you.
Send me your handle so I could give you the speaker role for speaking.
Okay.
All of our speakers are getting the speaker role so that we could, as recognition of thanks for speaking at our presentation. Yep, that's you.
Okay. Perfect. Yeah, I enjoyed this today. I know, you know, we could have gotten into a lot of different things about, you know, proof of stake, proof of work, and you know, but I think the bigger part is when I was first starting to look into cryptocurrency, the cryptographic aspect was the more important to me, because you start to get into the underlying technology versus just looking at it from a, you know, why is there Bitcoin? Why is there Ethereum? You know, and then you understand what's happening under the hood versus you're just like investing in something, and then you're kind of figuring out why there's such a interest in it, because it's been discussed about these things, but I think having an understanding about the blockchain is from a security standpoint too, being it's immutable and those things, that's what makes it fascinating to me.
Awesome. Awesome. Thank you very much. And for all those who attended, if you want to watch this again, that recording will be posted in our YouTube channel, which is youtube.com/HackMiami. I thank you very much, everybody. Join us at Discord. We're in touch 24/7. There will be events coming again. We're starting to gear up for DEF CON. So thank you very much, and we'll be seeing you soon.
All right. Thanks, everybody. Have a good day.